My name is Dwayne Williams. I'm a student at JTech, and today we're going to be going over all of the basic automotive systems of the vehicle that are needed in order to make your vehicle function properly. The first system that we're going to be covering is the engine, and how the engine works is basically that the engine takes chemical energy and converts it to mechanical energy in order to power the vehicle. The engine block is the largest part of the vehicle, and inside of the engine block you can find the bearings, the crankcase, the camshaft, and you will have parts where you see like this, where you can see the different holes and all of the different ports that lead to the engine block. Here is the part of the engine that has been taken apart, and here you can see the cylinders, and this is where the pistons would be. These pistons are in really rough condition, but that's what moves up and down to create your combustion inside of your engine. On the ground here, as you can see, we have a flywheel, and what this does is it mounts to the back of the engine and connects to a automatic transmission in order to turn the torque converter and convert power through the transmission and into the rear wheels. Here, as you can see, we have a piston. This one, as you can see, the arm broke off of the piston, which means that it's definitely time to be replaced, and the piston is what goes up and down and creates combustion inside of the engine block. Here we have a crankshaft out of a vehicle, and what this does is it takes the up and down motion of the pistons and converts it into a rotary motion. Here we have an automatic transmission, and basically what the main difference between an automatic and a manual transmission is that with an automatic transmission, it can automatically input and select the gear it needs without any requirements from the driver. And as you can see, there's the input shaft where the torque converter goes, and the torque converter is what we are going to cover next. Here we have a torque converter that is sitting on an automatic transmission, and what this does is the torque converter will connect to the flywheel that connects into the mounts onto the back of the engine, and that helps transfer the power from the engine into the transmission and into the gear that it needs so that power can be dispersed as needed. Here we have a 5-speed manual transmission, and basically the one main difference with the manual transmission is that inside of the transmission it is made up of a series of gears and bearings that sit on the shaft, and they move in position as you select that gear. And also here you can see is the shifter that would be how you change to the desired gear in order to get the speed or power that you are looking for. Here we have a clutch assembly, and this is what helps to change into the gear that you need. As you see, you have all of these different teeth and rings, and as you select the gear that you need, it moves across, and the size of it changes depending on what gear you have selected. On most vehicles such as this one, when it comes to the steering system, there are 4 main parts of the steering system, which are the most important and the main ones, and we're going to cover those. As you can see, this vehicle uses a rack and pinion steering system, which means that here you have, this is connected to, you have your outer tie rod, which is connected to your inner tie rod, and they work together with a series of steering fluid going through them to operate and turn your vehicle. And a rack and pinion system is a little bit more responsive and a little bit better off than a parallelogram system, and it's honestly all about preference. As you can see on this vehicle, we have the steering wheel, which is connected to the steering column, which runs down to the steering box, which is on the other side of the firewall. And what that does is that it takes it and it converts the rotary motion of the steering wheel to the linear motion needed to pivot each of the wheels. There are a series of steering linkages that transfer the effort to the wheels by connecting the steering box to the steering arm on each of the steering knuckles, which also contains the pivots and the ball joint. As you can see, down there is the other half of the steering column, and it runs down to the steering box and the rest of the steering system, which you cannot see at the moment because of the motor and all of the other parts that are in the way. But it is all one system that works together to turn the wheels depending on how far the driver turns the steering. Okay, so the next thing we're going to cover is the steering and suspension system. And each vehicle is a little bit different in the way that the steering and suspension is set up. On this particular vehicle, you have a series of shocks and coilovers in the front. You have a set, and you have shocks and leaf springs in the back, which as you can see, the leaf springs are connected to the axle to hold them in place. And that you have back here, just the axle runs straight into the tire, and you have all your power lines and your brake lines, and your rear differential and your axle, and you have the shocks run in connection with the leaf springs to dampen and soften your ride. And we'll go look at the front of the vehicle next. As you can see, the suspension system in the front of the vehicle is a little bit different. You have shocks that have coils on them, and you have your control arm and your inner tie rod, your outer tie rod, your sway bar, you have your ball joints, you have everything that is needed to control how the front wheels of the vehicle go up and down and how the way they turn. But you can change this depending on how you want your vehicle to ride, but this is the basic system required to control the front part of the vehicle steering suspension. Most vehicles have two different types of braking systems. Usually you have a system that is a disc brake system and a drum brake system, and on the front tires of this vehicle you have a disc brake system. And what a disc brake system is a disc brake system has a rotor that is connected to the wheel hub, and on the rotor sits the actual disc brake itself, and the rotor and the disc brake turn with the wheel hub, and they all turn at the same motion, and that way when you hit the brakes, the disc brake just squeezes the rotor and creates contact, and that's what causes your vehicle to stop. On the back of this vehicle, it has drum brakes, and basically drum brakes work similar to disc brakes. They sit also as well, the drum brakes sit on the wheel hub. They sit on a rotor connected to the wheel hub, and they move at the same speed the wheel hub moves at. It's just that drum brakes are a little bit more complicated, and they use a series of springs and wires to create a connection that stops the vehicle, versus where disc brakes just have two pads that squeeze the rotor. Here you can see here's the rotor, and it's connected to the wheel hub, and it spins in one motion. This particular setup would be set to run a disc brake, and as you can see, the disc brake would normally sit somewhere in through here and put pressure. When you hit the brakes, it applies pressure to the rotor and causes it to stop, which in turn stops the wheel. And now we are going to cover disc brake or drum brakes in the next video. As you can see here, we have a drum brake that has been taken apart, and basically what this does is this sits on top of this and helps keep it protected, and it's part of what helps stop the vehicle. When the brake is applied, it puts pressure on these springs, and these will expand and widen and put pressure on this case so that it stops the hub from spinning. And that's basically the way it works. Just they do the same thing as the disc brakes. They're just a little bit more complicated to take apart and work. Okay, so the next major system that we are going to cover is the heating and air system. And for the AC system, you have your condenser, which is right there, and we have the compressor is down here. This is the actual line for the compressor that runs down. It's probably located somewhere down below the side of the engine. And the AC system uses four main parts. It uses a refrigerant, and then you have your four main parts, which are your condenser, your compressor, your evaporator, and a restrictor. And basically the way the AC system works is that it stays in a circuit and it pulls the hot air from the engine to help cool your engine, and it blows it out through your radiator fan so that your engine will stay cool. And it takes it and it flows back through, and it turns it into cool air, which goes through your cabin filter and that's how you get your cool air inside of your cabin. For the heating system, you have your water pump, which is this one right here. You have your thermostat and your radiator and your upper and lower radiator hose, and basically what happens is that when the water in the engine starts to get too hot, the pump will kick on and it will push water through the upper and lower hose, and it flows out. That way it keeps the engine cool, and the thermostat is what determines when the water inside the engine is getting too hot, and then it needs to flush the system and cool the engine. Okay, so the next system that we're going to cover is the electrical system, and basically the electrical system is where everything starts. For the electrical system, you get all your power to power all your things, such as your radiator, your fans. Everything that needs power starts with the electrical system. And here you can see we have the under the hood fuse box, and here you can see we have a set of fuses and relays which can help control everything inside the vehicle. And as far as the starting system, the electrical system, you have other components. You have a series of wires and connectors such as you see here that run throughout the vehicle, and you have your battery, your alternator, and your starter, which is buried down below the left side of the engine. These are all the things that help your vehicle run properly and ensure that power gets to where it needs to be. Remember that from time to time you need to make sure that you inspect and service your vehicle regularly as needed. You want to make sure that you inspect under the hood, inside of the interior, the exterior, your tires, wheels, brakes, everything that is important for the vehicle, and to make sure that you're not having any sort of problems. And you want to make sure that you regularly check your fluids, such as your engine and brake fluid, your oil, your engine fluid, your power steering fluid, windshield wiper fluid, all those kind of things. You want to make sure, even check your water in your radiator, check your windshield wipers, make sure you check that. Walk around the vehicle, you want to make sure that you check your tires and make sure that they're in good condition. Check your brakes, make sure everything is working and functioning properly. That way you don't have to worry about having any sort of problem. Also remember to check your serpentine belt, or your car may have a V-style belt. Make sure you check that. Make sure you look for any sort of like cracks or tears, anything that could indicate that your belt may need to be replaced, or even if the teeth are starting to get worn down, make sure you check that, because if it breaks, you're going to be stranded on the side of the road and have to call for somebody or have to figure something out, so you don't really want to have that happen. Here's a diagram of the basic 4-stroke engine, which is the most commonly used engine. And as you can see here, we're going to display each stage of the 4-stroke engine. As you can see, if you read, it shows you that the exhaust stroke, you have the intake valve is closed, exhaust valve is open, piston's going up and pushing the burnt gas out of the combustion chamber. And as you look, we have where you can read what happens in each stage of the compression of the engine.